We just found a black hole so heavy, it could swallow our sun 36 billion times over, and it was hiding in plain sight. But here's where it gets controversial. The way we spotted this monster may upend the very rules astronomers use to rank the universe's biggest black holes. A cosmic record breaker hiding in a horseshoe. Cast your mind back to 1964. A small sounding rocket punched above Earth's atmosphere, and for a few minutes scanned the sky in X-rays. The data it brought home revealed the first black hole humanity ever confirmed, Cygnus X1, a 21 solar mass beast lurking 7,300 light-years away. Fast forward 6 decades, and the scoreboard has exploded. We now catalog thousands of black holes, from city-sized stellar corpses to supermassive titans millions of times heavier than our sun. Today, a new name is elbowing its way to the very top of that list. In the latest issue of the monthly notices of the Royal Astronomical Society, PhD candidate Carlos Melo, Universidade Federal do Rio Grande do Sul, Brazil, and his team unveil a black hole that tips the cosmic scales at roughly 36 billion solar masses. That's not a typo. 36 billion suns compressed into a single invisible point. The heavyweight lives inside the Cosmic Horseshoe, a galaxy so gargantuan that its gravity bends background starlight into a near-perfect ring, one of the cleanest Einstein rings ever photographed. This object is almost certainly in the top 10 most massive black holes known, and it may actually be number 1, says Professor Thomas Collett of the University of Portsmouth, a co-author on the study. Why measuring a black hole is anything but simple. Headlines love superlatives, but scientists live in a world of error bars. Every mass estimate comes with a thicket of assumptions. How far away is the galaxy? How fast are stars moving? Is the black hole feeding and therefore glowing, or is it dormant and effectively invisible? Most previous, largest black hole claims rely on indirect clues, glows from superheated gas or broad spectral lines, whose widths hint at extreme gravity. Those methods can be off by factors of 2 or more. The Cosmic Horseshoe black hole, however, was weighed by a far more direct technique, gravitational lensing married to stellar dynamics. Think of it like this. If you want to weigh an elephant, you can either guess from the size of its footprints, traditional methods, or you can put it on a scale, lensing plus dynamics. The second option is harder, but the number you get is far more trustworthy. The two-pronged trick that made the impossible possible. 1. Gravitational lensing. The foreground galaxy acts like a funhouse mirror, distorting and magnifying a background galaxy into a bright arc. The exact shape of that arc encodes the foreground galaxy's total mass, including its central black hole. Number 2. Stellar dynamics. Even though we can't pick out individual stars in the Cosmic Horseshoe, the galaxy's innermost stars are whipping around so fast, close to 400 kilometers per second, that their collective motion leaves a clear imprint on the lensed image. Combine the two measurements, and the black hole's mass pops out with unprecedented precision. Professor Collett puts it bluntly. We detected the black hole twice, once by the way it bends light, and once by the way it flings stars. Either signal alone would be suggestive. Together, they leave no doubt. A dormant giant we should never have seen. Here's the twist that keeps astrophysicists awake at night. This black hole is currently off. It isn't guzzling gas. It isn't blazing as a quasar. It isn't doing anything flashy at all. In its quiet state, it should be utterly invisible across billions of light years. We only found it because the Cosmic Horseshoe's gravitational lens turned the galaxy into nature's largest telescope, magnifying the scene by a factor of 30. Without that cosmic coincidence, the black hole would still be hiding. Lead author Melo is almost gleeful. This opens a brand new window. We can now hunt for silent, ultramassive black holes across the entire universe, even when they're not lighting up the night sky. The plot thickens. A black hole that shouldn't be this big. And this is the part most people miss. The Cosmic Horseshoe's black hole appears too massive for its home galaxy. Plot its mass against the galaxy's stellar velocity dispersion, and the point shoots way above the standard trend line. In plain English, the black hole is an overachiever. like finding a 300-pound linebacker living inside a compact car. The authors argue this is no accident. The Cosmic Horseshoe may be the lone survivor of a fossil group, a once crowded neighborhood where several large galaxies danced together for billions of years until gravity forced them into a single dominant host. Every black hole from those swallowed galaxies may have merged into the one we see today. We are therefore staring at the end state of galaxy cannibalism, a final, bloated black hole that outgrew its final home. What comes next and why you should care? Radial arcs like the one in the Cosmic Horseshoe are rare today, but that's about to change. ESA's Euclid Space Telescope is expected to uncover hundreds of thousands of new gravitational lenses within the next 5 years. Meanwhile, the upcoming extremely large telescope, ILET, will dissect those lenses with a precision today's instruments can only dream of. Together, these observatories promise a census of black holes stretching back to when the universe was a quarter of its current age. The payoff? A direct test of whether black holes and galaxies truly grow in lockstep, or whether outliers like the Cosmic Horseshoe reveal hidden pathways we never anticipated. Your turn to weigh in. So, is the Cosmic Horseshoe black hole truly the most massive ever detected, or merely the most precisely measured? Could fossil group mergers be a common route to ultramassive black holes, or is this an exotic one-off? And if we keep finding overmassive black holes, do we need to rewrite the relationship between galaxies and the dark hearts that lurk inside them? Drop your thoughts below. Agree, disagree, or bring your own wild theory. The universe just got a little stranger, and the conversation is only beginning.